We can always simplify any rational expression by interpreting the main fraction bar as division. However, in some cases, that method is really inconvenient. In this example, for instance, we don't particularly want to divide by that denominator, because dividing by that denominator would involve first actually carrying out that addition, and actually carrying out that addition would involve finding a common denominator, and that's a little bit of work. Our second method is going to involve remembering. First, that we can always get an equivalent expression by multiplying the numerator and denominator by the same thing. For example, if we're just looking at fractions of numbers, right? If we have 2/3, we could multiply the numerator and denominator each by 7 if we liked. And get an equivalent fraction. The second thing we want to remember is that if we multiply a fraction by a multiple of its denominator, the result is no longer a fraction. So if we take that same 2/3 and multiply it by, say, 15, which is a multiple of 3, well, we're dividing by 3. We can do that division by 3 to the 15 instead. So we're just multiplying 2 times 5. That gives us 10. Okay, so these two facts together give us a way to get rid of the denominators within our rational expression. Here's what we're going to do. First, we'll find the least common multiple of all of the internal denominators. What do I mean by the internal denominators? I mean the denominators within the rational expressions we're putting together here. So in this example, we have an x squared, and another x. Well, that's an easy least common multiple to find, right? The least common multiple is just an x squared. And now we're going to multiply our numerator and denominator both by x squared. One way to think of that is we're multiplying by the fraction formed by our least common multiple over itself, which is, of course, just a fancy way of writing 1. So we're going to multiply our numerator by x squared and our denominator also by x squared. Right, so we need to distribute. And also distribute in the denominator. And now we notice that when we actually carry out that multiplication, all of our denominators are going to cancel out. What will we be left with? An ordinary rational expression that we can now carry on simplifying in the usual way. First, we'll factor the numerator and denominator. The results look like this. And then we cancel any common factors. And we're left with 2x plus 5 over x times x plus 4. And there we go. Now, this method works really well in examples like this one, where our internal denominators have an easy-to-find the least common multiple. In the next video, we'll see an example in which neither method is easy, and talk about how we select which method to use.